Why does AI make mistakes? Hi, I'm Dina Schlesinger. I asked Microsoft Copilot to create a graphic about postcards from around the world. And lo and behold, a postcard with the Statue of Liberty said Tokyo. I heard that AI can create mistakes, and I wondered why. I asked Mimi Coutier, who's a math teacher, to explain why at least the binary system can cause some mistakes. I'd like to introduce you to Mimi Coutier. She's a high school math teacher at the Park School of Baltimore. This is the question. You told me that sometimes computers, including AI, create errors because they use the binary system. Can you explain?
All right, so first I'll say that I think it's more of a communication error due to the fact that computers use binary, the binary system, but we humans use the decimal system, like the digits 1 through 9, right? We count to 9 and then it's 10. It's, so it's like an odometer, right? It cycles around. I'll explain a little more about binary, even though I'm sure a lot of people in the audience know what it is, but it's counting only with the digits 0 and 1, right? So if you look at what I have on the screen here, right? So 0 is 0, 1 is 1, but then you run out of digits after that, so you have to go to 1, 0, and that means 2, right? That's the next number. So that's how computers store all of their information. And then we have to go back to kind of middle school math and think about fractions and decimals. So in our decimal system that we all are familiar with, we've got fractions like 1/5, that they also have a decimal representation, 0.2. But also think of a fraction like 1/3, right? So if you go back to your middle school days, it's 1/3 of a pi, something like that. 1/3 doesn't have a nice decimal representation like 0.2. It has a repeating decimal representation, so 0.3333333, right? And I could go on forever, right? So, but it does. The decimal representation of 1/3 goes on forever. So, when humans use the decimal representation of 1/3, they have to round at some point. They can't keep the number going forever. And so that's all well and good. But then when we think about computers, right? So in the binary system, there are also nice decimals that stop and more annoying decimals that go on forever. And what the confusing thing is that those, whether a fraction repeats or not, it's different in decimal versus binary. So in the decimal system, the one familiar to us, 1/5 equals 0.2. But in the binary system, 1/5, you can read it on the screen, goes on forever. That's an infinitely repeating decimal. So the trouble comes in when a programmer forgets. They're thinking 1/5. They're like, oh, cool, 0.2. I'll just type that in the program, right? But then the computer, when it sees 0.2 and converts it to binary, it now actually has this long repeating binary string of numbers, and it needs to stop that at some point. Like computers can only store so many digits, which means it's going to round at some point. And if it only had to round once, that wouldn't be so bad. But if this is some kind of calculation going on a loop, like you have to use it over and over again, right? The more you say multiply by that number, whatever you're going to do with it, the more the errors compound until you get some very serious error.
Great, I get it. And now for real world examples. I read that a rocket crashed because of the way the programmer stored numbers in this binary format. Can you explain that? Why that crash happened?
Yeah, so this crash happened in 1996. It was the Ariane rocket, and this was part of the European Space Agency's program. So what happened with the rocket was that there was an Ariane 4, and that was all fine. Everything went well with that. But in updating it to make the Ariane 5, the programmers reused a lot of the code. What they didn't realize was that using some of the, with the old code in there, they had a long number, a big number, which was stored as what's called a float, which is 64 bits. And bit is binary digit, so it's just like one of those zeros and ones that you see on the screen. So it's 64-bit number, but the program needed to convert it to an integer, which only has 16 bits. And when it did that, it overflowed. It was okay for a little while, but once the number got big enough that it really mattered, that it could only store those 16 digits, then things started melting down. The rocket crashed. The satellites on it were destroyed. It was a financial disaster. So that's a pretty elaborate example of rounding error.
But it's a very good one. Thank you so much, Mimi. The binary system is the underlying code of the FAI, but AI operates using the large language model. And here's a 40-second video explaining how it works.
I hope by the end of this video, you'll be able to easily explain exactly how LLMs generate text. Imagine you're playing a guessing game. If I say it's raining cats and you say dogs, you just predicted the next word. That's exactly what a large language model does, but at a massive scale. It's trained on trillions of words, learning how language fits together. When you give it a prompt, it breaks your text into tokens, tiny pieces of words, and predicts the most likely next token based on patterns it learned during training. Then it keeps predicting one token at a time until a full response forms. So at its core, an LLM isn't thinking, it's predicting, but it's doing it so powerfully it feels like intelligence.
I asked AI to create a graphic to explain why large language models make mistakes. And AI answered that it doesn't understand facts the way humans do. The computer predicts the next word based on patterns in their training data. This means that they can sound confident while being wrong. And if there are errors in the data, they're going to be compounded in the results. Here are some real-world examples of AI errors. In Arizona in 2018, a self-driving Uber with a human safety driver behind the wheel struck and killed a pedestrian as she wheeled her bicycle across a highway. The autonomous system was not designed to recognize pedestrians outside of crosswalks, and its emergency braking features were disabled. Uber settled with the victim's family to avoid a trial. So it's not a matter of the binary system, but of a lack of data that can cause errors. Another example, the Gordon Weiss law firm, with a gross income of $800 million in 2024, apologized profusely to the judge because it submitted a bankruptcy filing riddled with errors. Recently, Elon Musk got a $1 trillion stock bonus because he designed a robot that will do household chores like cooking and cleaning and driving. They will sell for about $70,000 now, but Musk thinks the price will go down to about $20,000 each. Eventually, Musk thinks that they will assist in manufacturing and even perform medical operations on people. But the Tesla Optimus robot makes errors with its dexterous hands, including overheating motors, weak grip strength, and low durability. They perform poorly compared to human workers and lack precise control and heat management of its joints and fingers. And that's how they create errors. Raul Janaju is an 18-year-old prodigy from India, and he feels that AI models face a limit of how intelligent they can become due to mathematical and data constraints. His video is called AI Has a Fatal Flaw and Nobody Can Fix It. I advise you all to look at it. It's fascinating. Raul thinks that computers are great with math operations and memory and recall and general reasoning. And it can pass an IQ test handsomely. But it's not good with common sense and creativity where it's needed in math formulas. But Raoul says that as computers escape containment, the set of human capacity skills is shrinking. Raoul says that there are 175 billion parameters now, and in years to come, he thinks there will be 180 trillion. Geoffrey Hinton is sure AI is a threat to humanity. It can create fake content, upend the job market, and be uncontrollable in the long run. And AI systems may start to think for themselves and take over or eliminate civilization. Hinton quit working for Google in 2023. He got a Nobel Prize in 2024 to start warning the world about the need for constraining AI. And now he's a chief scientific advisor at the Vector Institute. So I still don't understand how AI made a picture of the Statue of Liberty say Tokyo, but when I asked it to correct itself, it did. Singularity will happen when AI, they say, surpasses human intelligence. Some things it's inevitable, but the timeline and ultimate impact are unpredictable. Others believe its effect could be gradual and not immediately evident to people. So I'd like to throw this out now to what you think in the audience. Will you buy a Tesla robot to clean your house and cook? Will you use driverless cars or taxis in New York City? How can people stop AI from making errors in briefs and homework essays? Do you think AI will ever take over the world? What can people do to contain AI?